Hello, everybody. Welcome to this week's class, this week's lecture video on impact of aggregation on safety inventory. So we talked about safety inventory in the videos that I posted last week. We talked about the basics of safety inventory, why it's required, and so on. This week we'll talk about the impact of aggregation. So aggregation can happen for different reasons. Um, uh, because two companies are merging. Aggregation can also happen because you're trying to figure out which design is better, whether it is better to have 10 different locations where you store inventory or have a single location where you store inventory. So the most common reason to think about in aggregation is when you have the concept of centralization versus decentralization. So we'll talk more about that in this video. So this week, for this part on the impact of aggregation, we will separate this out into maybe 4 different videos that I'll be posting on Canvas, maybe 5, depending upon how long each of these videos go. I don't want them to be too long, as you know. Right? So let's begin. So in this, how does aggregation affect the forecast accuracy and safety inventory? So that's basically what we're going to talk about. So let's assume that there are k different demands, k different regions in which you're selling the same product, and the average demand per week in each of those k different regions is given by d sub I, and the standard deviation of weekly demand in each of those regions is given as sigma sub I, right? So for the K region, so this will go from sigma 1, sigma 2 all the way up to sigma K, D1, D2 all the way up to DK. Now we will also assume that demand in different regions is correlated. Now this is a very, very important piece, right? So in a lot of calculations, we assume that we will assume that demand is not correlated, but in reality, demand is correlated. Say, for example, if there is a particular neighborhood where people tend to buy, say, Toyota cars, and there are a lot of Toyota cars around, and people like those Toyota cars, it's likely that their neighbors will buy Toyota cars and the places nearby will buy Toyota cars. Maybe there's a Toyota dealership nearby. That's why there are more people buying Toyota cars. So what this tells you is that these two neighborhoods that are next to each other, their demand for Toyota cars are related to each other, right? So there is some correlation in demand. If there is a sudden increase in demand in one region, it's likely that you will see a similar increase in demand in the second region. So it's important to keep correlation in mind. So with this, what we can see is that the total safety inventory, so if we have decentralized inventory for the K different regions, we will look at each of them separately. So we'll assume that the lead time is L. So for each of these regions separately, if we assume that we need to keep a cycle service level of CSL, then we will do the usual cycle service level calculation with the normal distribution or any other distribution, square root of L sigma I. So we'll calculate this out, right? And that will be the total safety inventory that you require. So you calculate the safety inventory separately for each of the K regions. But what if you were to combine all the K regions together? So if you're combining all the K regions together, then the demand will be the sum of all the average values. So the average values always can be added up together, but it's the standard deviation where you see the square root, right? So you square the individual standard deviations, and then you add them all up, you put them under square root, but that will only work if we assume that there is no correlation in demand. So with correlation, you multiply the correlation and the corresponding standard deviations, you add them all up and you multiply them by 2. So why this multiplication by 2? So this is basically like a plus b whole square. So that's where we get all of these ideas from. So yeah. So right. Now, and so that's the idea here. Now, then we can calculate the standard deviation of demand for all the K regions together if you're putting them all into a single place. Now, this formula here is a pretty complicated formula. I mean, at the end of the day, if you only have a few regions, this is really not that complicated to calculate. But what if what are the different ways in which you can simplify it? One simplification is that we can assume that the standard deviations for all the different regions are the same. So instead of having sigma 1, sigma 2, and so on, you have sigma, which is a single standard deviation for all the regions. And we can also assume that the correlation coefficient is the same between all of these different regions. So if you make both of those assumptions, then your average demand will just be k times the average demand, because the average demand is the same, the standard deviation is the same, and you can calculate the standard deviation for all the regions using this formula, which is k times sigma square plus k times k minus 1 times sigma, rho, the correlation coefficient, times sigma square, right? So that's the formula if there is a correlation coefficient. Further, we can further simplify this to if the correlation coefficient is zero. So if you assume that demand in all the regions are independent of each other and there is no correlation in the demand, then we can further simplify this formula to square root of k times sigma d, in which case you're just looking at k different things. You're adding up the standard deviations and you're taking the square, adding up the variances, you're taking the square root, and you end up with square root of k times sigma d. So remember, if the standard deviation of demand for each of the regions is different, then we use the different sigmas, and the correlation coefficient is different. This is the formula that we have to use. If we assume that the standard deviation and correlation coefficients are all equal to each other, this is the formula that we're going to use for the standard deviation of the aggregated demand. But if we further assume that there is no correlation and the standard deviations for all the different regions are the same, then we will use this much simplified formula, right? So this is the formula if you have no aggregation. So if you're decentralized everything, this is the average and standard deviation of demand if you centralize everything. So the with aggregation, this will be the this will be the difference between the two, right? So this is what you have for the decentralized option. This is what you have for the centralized option. The difference gives you the savings in holding costs, because when you decentralize it, you have to have more inventory at each of the individual places. So you will hold more inventory and you will have higher holding costs, right? Now, that's not always a bad thing, as you will see in a few minutes, right? So this is the formula that we use. Again, the formula might look complex. Don't worry about that. We will do some examples and you'll see that the calculation itself is actually pretty straightforward. So when looking at the impact of aggregation on safety inventory, there are many different aspects to this formula here. So each of these has a different effect on safety inventory. So the safety inventory savings on aggregation increase with higher service levels, right? So if cycle service levels are higher, then the value of F inverse will be higher and the holding cost savings will be higher. The same goes for safety inventory savings on aggregation increase with replenishment lead time. So if it takes longer for you to get replenished, then you say it's better to aggregate. Your holding cost reduction will be higher. Safety inventory savings are higher with the value of holding cost itself. It's very expensive to hold inventory, then it is better not to hold as much inventory. And holding cost is inventory is higher. Again, with higher coefficient of variation. We'll talk more about coefficient of variation when we come to it, but that's one of the things. And finally, safety inventory savings on aggregation decrease. So this is the only one where we see a decrease as correlation coefficients will increase, right? So if the correlation between the different pieces are higher, then your safety inventory aggregation will decrease, right? Because demands are correlated with each other, then maybe you should not be aggregating items. You should have separate items, right? Again, we will see this in a second. So let's look at a simple example, right? Or let's look at an example. You might not find it simple. So there is a BMW dealership that has 4 retail outlets serving the Chicago area. So let's first look at the disaggregate option, that is, we are not putting them together. We'll say that the weekly demand at each of these outlets is normally distributed with a mean of 25 cars and a standard deviation of 5 cars. So this is the weekly one. We'll assume that replenishment lead time is fixed and it is fixed at 2 weeks. Now, we'll assume that each outlet covers a separate geographical area and there is some correlation in demand across any pairs of these areas, but we'll assume that the correlation is constant at rho. So it's the same correlation. So the standard deviation is the same and the correlation is the same. So remember, of all these different formulas that we have, if correlation and standard deviations are different, we use this formula for the standard deviation of demand, of correlated demand, of aggregated demand. But if correlation and standard deviations are the same, then this is the formula that we'll use for a standard deviation of the aggregated demand. Okay, that's what we're going to use. Now, if we aggregate them into a single outlet, so the dealership is considering the possibility of replacing the 4 BMW outlets with a single large outlet. Assume that the demand in the central outlet is the sum of demand across all 4 areas. And for both of these cases, BMW is targeting a cycle service level of 90%, right? So 90% of the time during the lead time, you will be able to satisfy demand. Now compare the level of safety inventory needed for the two options as the correlation coefficient varies between 0 and 1. So just to in case you guys don't remember, correlation coefficient tells you how much two different distributions are related to each other. If correlation coefficient is 0, which means that the two demands are not related to each other at all. And if correlation coefficient equals 1, it means that one demand and the other demand are essentially the same. You're not looking at two different instances of demand. They're perfectly correlated to each other. So if you know one, you know exactly what the value of the other is. And usually correlation in most real life cases varies somewhere between 0 and 1, right? So with this data, let's evaluate the two options and see what we get. In the case where we are keeping them separate, so the weekly standard deviation of demand is 5, replenishment is 2 weeks, replenishment lead time is 2 weeks, and cycle service level is 0.9. So the safety inventory, we can calculate safety inventory for each of these separately. So for each region, it will be the norm dot inverse of the cycle service level times the square root of L times sigma d. So remember, square root of L times sigma d gives you the standard deviation of demand during lead time, and you multiply that with the normal inverse of the cycle service level. That will give you the safety inventory for each individual region, and you multiply that with 4, and you'll get the total safety inventory required over all 4 regions, and assuming you have decentralized it, and the total safety inventory required is 36.25 cars, right? Now, with assuming that the correlation coefficient is 0, because the problem says look at different values of correlation between 0 and 1. So let's initially look at the case when correlation coefficient is 0, in which case the standard deviation of demand at the central outlet will be, because you have aggregated everything into a single place, the standard deviation of demand in the central outlet will be 10. And so again, using the normal inverse of 0.9, because that's the cycle service level, times square root of 2 times 10, this will give you 18.12. So if you have a single outlet, then you will only hold 18.12 cars in inventory as opposed to 36.25 cars in inventory when you have 4 separate outlets, right? And as you change the value of rho and you apply this formula here, as you change the value of rho and you apply this formula, you will notice that the amount of aggregate safety inventory that you hold will change. So initially, when there is no correlation between the two, the aggregate the inventory, the separate inventory that you hold over the 4 places, no, that remains the same for the whole case. So the aggregate inventory starts at 18.12, and as correlation increases, you'll notice slowly that the aggregate safety inventory increases, and when demand is perfectly correlated, then aggregating is the same as disaggregating, and you'll end up with the exact same safety inventory, right? That's the impact of the correlation coefficient on aggregation, right? So that's one thing to keep in mind. But one of the important pieces here is that we assume that there are the two options that we're always considering is we have multiple outlets versus having a single centralized outlet, right? But centralized, and this sort of seems to show that the centralized outlet is always better, but that is not the case, right? That's not always going to be the case. So let's look at this example. I know this video is already getting longer, but I'm going to go over this example and then we'll switch to the next video, right? So what is the impact of correlation on the value of aggregation? Now, there are two possible disadvantages to doing aggregation. One is that the response time to customer orders will be higher because instead of having multiple service centers, you have a single service center, so all your customers have to come to a single place. Or if you're shipping things to customers, then having multiple service centers means that you have multiple places from which you can ship, so your transportation costs will be lower. But if you have a single place from which you're shipping everything, your transportation costs will be high, right? So let's look at a particular example of this particular case, right? So let's assume that there's an online retailer which is debating on whether to serve United States. So let's assume it's Amazon, right? It's the simplest thing that we can know. So Amazon is trying to figure out, should we have 4 regional distribution centers or 1 national distribution center, right? So that's what they're debating. Now, weekly demand in each region, each of those 4 regions, is normally distributed with a mean of 1,000 and standard deviation of 300. So there are 4 regions with average demand of 1,000 each and a standard deviation of 300. Now, the demand experience in each region is independent. So correlation is 0. There's no correlation here, right? And the supply lead time is 4 weeks. So it takes 4 weeks for your order to arrive. Now, the online retailer has a holding cost of 20%, and the cost of each product is 1,000. So basically, you're paying $200 to hold it in inventory for a whole year, 20% of 1,000. Now, the retailer promises customers next day delivery. Now, this is actually pretty common. Let's say if you're delivering blood to blood banks, then you have to deliver it within the next day, sometimes even within the same day. Now, with 4 regional distribution centers, the retailer can provide next day delivery using ground transportation for just $10 per unit. But with a single national distribution center, the retailer will have to use a much more expensive mode of transport. So either use rail or air, and it'll be higher. So per unit cost will be $13 per unit instead of the $10 per unit. And that's the disadvantage that we're talking about. Further, but one other thing is that having 4 different regional centers costs you $150,000 per year more than building and operating a single national distribution center, because you'll have a single distribution center, right? So even though the cost here is $10, is $3 more per unit, it is cheaper to have a single center rather than having 4 centers. Now, what is a distribution? What kind of distribution network do you do? Do you do a single center or do you do 4 different centers? We are assuming a required cycle service level of 95%, right? Okay, so let's calculate both. So let's talk about the 4 regional distribution centers first. So if you look at each of them separately, so norm.s.inv of 0.95 times square root of L times sigma d. So this is the standard deviation of demand during lead time times the inverse of the normal distribution times 4, because we have 4 different regional centers and we're doing them separately. We are looking at inventory separately. And so the safety stock is 3,948, almost 4,000 units, right? So keep that in mind. Now, but if you have a single national distribution center with no correlation of demand between the 4 regions, so the standard deviation of weekly demand will just be square root of 4, there are 4 regions, times 300, which will be 600. And with that, we can calculate the same norm.s.inv with 95% cycle service level times the square root of 4. Now, this 4 comes from the fact that we have 4 regions, and this 4 comes from the fact that our lead time is 4. So it just so happens that they're the same, but they can definitely be different numbers. Times 600, the standard deviation of weekly demand. So this gives you a safety stock of 1,974. So there is a huge difference between the two. So if you look at the holding cost difference, so you're definitely holding more when you have 4 different regions. So what is the cost of holding 4 different regions? So that'll be 3,948 times 1,000 times 0.2. So there is a decrease in holding cost by um, by going to a centralized service center. And there is also a decrease in facility costs. So you're paying $150,000 less because you're running a single facility rather than four facilities. So this total that you get, so this will be I'm sorry, 394,765 plus the $150,000. This will be $544,765. That is how much you're paying less for having a single national distribution center. But on the flip side, you're also paying extra for transportation. So you have 1,000 times 13 minus 10. So this is weekly demand, remember. So 52 times 1,000 times the $3. So you're paying $624,000 extra for transportation. And the savings that we had was $544,765. So even though we save $544,765 by having a single facility, the $624,000, which is an increase in transportation, means that you are much better off having four separate regional distribution centers rather than having a single centralized distribution center. Now, if you can get the transportation costs down, say from 13 to 12, this might be a completely different picture, but given the cost of transportation being 13 per unit, it is much better to have four separate uh, distribution centers, right? Right. Okay. So I'm going to end this video here. So in this video, we talked about what are the benefits of aggregation and what are the trade-offs that you might have for aggregating and centralizing. So what we'll do in the next few videos, we'll talk about the concept of specialization. We'll talk about the concept of product substitution, component commonality, postponement. There are lots of different things that we need to talk about. So like I said, there'll be about 4 videos this week, right? Okay, I'll see you all in the next video. Take care.